Hello, welcome back to Sabretooth and Nethemba, where we care about your security. The last box we did on Try Hack Me was Ra in hard. We're closing off THM. We're going back to Hack the Box. The last Hack the Box machine we did was Kronos. Okay. 10, 10, 10, 13. So I'm assuming the next one is 10, 10, 10, 14. But it might not be because they do skip them every now and again. We're going to go to retired machines, see what's next. Hopefully it's not the insane one yet. Can't really be doing with that just right now. Oh, it's coming up. We're on October. Okay. Straight onto adventure mode. And we're going to spawn the machine. And I'm actually going to revert the machine once it's started as well, just because I like to start getting into that habit, quite honestly. For Try Hack Me, it's not a problem because you get a brand new system each time. Whereas this one, it's still shared unless I get VIP Plus, which is not quite worth it. In my opinion. So, excuse me, we're going to wait for this to start up, and then we are going to revert immediately. But whilst we are doing that, we are Hack the Box medium, adding a subnode. October. I wonder what this system is about. The fact that it's currently end of July doesn't really matter, I'm sure. I wonder if it's Halloween themed. Maybe not. Well, just out of curiosity, whilst this is not doing anything. Oh, let's connect to the network. That would help, wouldn't it? Sudo open VPN HTTP. Okay. Make directory in boxes called October, and then change directory. Out of curiosity, search exploit October. Content management system. I wonder if that's what it is then. CMS. Let's see. We're going to revert anyway. So it's going to take another couple of minutes to start up, but let's just take a look at this, assuming that it's this is what we're up against. Upload protection bypass, that's a Metasploit module. Nice. Multiple vulnerabilities. I mean, that could mean anything. Let's open that up and take a look. Whoops. I don't think it's cheating using the box name to get ahead before you start, you know. What do we have here? PHP upload protection bypass. Authenticated user permission or with permission, so we need access to the thing first, assuming this is what it is anyway. Blocked extensions of PHP, PH3, P3, PHP4, PHTML. We can upload alternative extension, such as PHP5. Okay. What else do we excuse me, have in here? Number 2, Apache htaccess upload. Interesting. To add a handler for PHP files, so that could be quite good, I suppose. Authenticated user with permission can store WCI payload in the image name. Okay. Payload is executed when the victim clicks on the image name to edit it. Well, that won't affect us then. Reflected WCI, again, not too bothered. PHP code execution. Anyway, let's take a look, see how this is doing. Still spawning. Delete file via PHP object. Okay. Injection. I'm not sure why we should be deleting things. I understand uploading and bypassing. Asset safe path modification. Okay, so that's just a local file inclusion, but it is sort of saving the file there. Got it. Okay, so quite a few there. what else do we? Oh, we've started, guys. So let's run. Let's leave that open and run nmap. T5 A. Should we do all ports? It might take a while. We'll do all ports. It means we can carry on looking through these. Cross-site scripting, we're not worried about. Arbitrary file read, I assume that's the same as the upload. Maybe. Cross-site scripting, CSRF, not important. So the only other one really is this file read exploit, authenticated. Let's take a look at this as well. Just in case we're up against October CMS, it makes sense due to the box name. So I truly don't see why not. Okay. Tested on version 1, okay. Enter the target host, enter the cookie, and you should be able to read files from somewhere. E.g. config database, oh I see. To get the database access credentials, etc, etc. Got you. That doesn't look too complicated, I guess. Okay, nice. So we've got a couple of things there which we can come back to if we need to. I was going to say let's check how long there is to go, but as it happens, we are done. It's done all ports. There's only SSH, which is running Ubuntu, and port 80 running October CMS. There we go. And we've got the put method as well, which is quite interesting. We might be able to put things on the server using that. Okay, well, let's go immediately then to port 80, as that's the only one other than the view forum, blog, accounts. So these are all here. Let's have a look at accounts. Sign in into your email, and it's an email. So we can't even really put like username, brute force or anything here. Maybe I forgot password. Enter your email. Okay, that's not good. How well can you guys see me? It's really dark in here. It looks okay, I suppose. I'm just going to get a light on. Okay, so let's not forget our normal methodology. We're going to go robots.txt because that's quite useful. We're going to go buster this because that's quite useful. Should we use a raft list? I've started using those a lot more now. Can I do that and just put in go buster? There we go. So that's for the previous system that we did, 10.10.14. All I really need to do is change that to 16. And the word list, raft list is already there, so I'm just saving a bit of time, you know, doing this like this. So we've got all these, config. We've got config directory here. Could be useful. Let's take a look. Page not found. Okay. Accounts. We've just been to account, that's here. That's blog. We've got modules and plugins, but both of them are 301 redirect. The other two which are okay are forum and blog, and then we have error and account, but these are all up here. So tests. Oh, tests. Okay, maybe. Let's take a look. Oh, that's not good. That's my fault. Tests. Page not found. Backend 302. Okay. Backend. Oh, okay, we found an admin area. Let's take, I was going to say let's take this so far, but can't while it's running. So GoBuster shows that backend exists, and this is an admin login portal. Okay, what do we normally do? SQL injection, and then we try our regular whatever. So 1 equals 1. Right. No. Admin password, etc, etc, etc. Okay, so admin. This is the first time, you know that we try this every single time, and this is the first time it's come to that. Okay, right, let me just go through another way of doing this in a minute. You know that I basically just try these things manually and then we brute force, but it's not good brute forcing without having a username there, so you need to find the username first, etc. What I think you should be able to do is October CMS default credentials. If we Google that, there's every chance. So this is on October CMS's own website here. I installed October. Is there a default place I can set this? And somebody says it's admin. That's a moderator of the site. Admin. So people are saying, you know, the default username. Always make sure, and here, default username admin. So you don't really have to guess. In fact, that even shows backend as well, right? You don't really have to guess if you do research, but as it happens, I went the guessing route. What can we do here? We can add, oh god, a file name with code. Might be able to do some PHP or something there. Components. What's in components? Oh, we've got CMS media blog user set. Let's check settings. Let's just user settings. Blog settings, media. And let's check media. Oh, we can import. That's quite useful, probably. Let's check media as well. That's interesting. So I reverted this machine. This is a brand new system, and somebody's uploaded a PHP 5 script. Do you remember that we just saw that October CMS thing from here? Multiple vulnerabilities, which said you can upload PHP 5. That's kind of proving it. Okay, this is the way we get a shell on the system, isn't it? This is the way we get a shell on the system. Okay, so what we'll do is we're going to copy, should we go for C99? That one works like 50% of the time, but it's one of my favorites when it does work. So we're going to copy that here. We're calling it C99.php5. And then it's just a case of using upload, I think, to upload the PHP5 folder, right? No, PHP5 file, that's the one. Box is October C99.php5. Nice, that's uploaded. And it says click here to run. I guess that's how you run. Oh, you can see at the bottom left it says storage app media C99.php5. Click that. No, is it not working? Oh my god, it's working. So we have this amazing C99 shell. This is my favorite web shell out of all of them. This is my absolute favorite. You can do so much here. You can run commands on the system. You can even, for example, if we try and find all config files, what we'd do, we'd upload linpies, right? And it would show us all the config files and so on. But if you do it here and execute it, not only does it show you all the config files, but it also shows you the command, or at least it should do. Let's wait and see. Make sure this works first. Don't forget it's searching the whole system, so it might take a while. Let me update my notes while this is running. We can go to components, media, and upload a PHP5 file due to file name filtering or blacklisting or whitelisting, whatever you wish, right? Whitelisting, I think. So we uploaded c99.php. Well, c99, that's it. And then I might just put the URL here. Okay, That doesn't actually seem to be doing anything though. I did say find all config files. What if we find all config.inc.php files instead? Let's run that. Hang on, let's reload it just in case something's gone wrong. Let's find all HT password files. How about that? Execute. That might not take us long. It might take us long. But you can see that we are www data. You can see that we are kernel 4 safe mode is off. You can see the current directory here, which is nice. Apache PHP 5. Okay, so for some reason some of these don't seem to be working, and I'm not entirely sure why. Oh, it is working. So that's where the results are, but there aren't any, and that's the command it runs. So you can see how Limpy's works now. It tries things like this and so on. Okay, this seems to be quite a slow system. It's here as well. But I could do something like who am I www data, and I can do things like I can get a proper reverse shell using this, and so on and so forth. Shall we get Limpy's anyway? Let's get a reverse shell first, a proper one. Let's get a proper one. So I could use this to upload a interpreter shell if I wanted, but there's no real need. There's no real need. So we're going to do nc. Hang on. Let's nano priv. No. Yeah, priv s scripts php. No, it's going to be in shells, isn't it? I mean, I don't have to do a PHP shell. PHP shells, as we know, are usually quite bulked. So what about if we do an actual bash shell as we're running, as Linux natively runs bash? Why don't we try that instead? So I'll go to hack resources and then reverse shells. And we'll just try this first thing here, bash shell. What is the RIP? Oh no, it's still running. I don't need that anymore. Let's kill that. Config. I don't need it anymore because now I can see everything anyway just by using an ls command. 10 10 14 10. Oh yes, I remember. 10 10 14 10. Nice. So I'm sure I just did this, but I didn't. Nano shells PHP reverse shell. 10 10 14. What was it? 10. Okay, so there we have it. I don't know why I did that. What am I doing? I'm not using PHP shell. I just totally, I was like, why did I do that? Forget it. It needs to go in here. Oh, brain, please work, Right. Yes. In here. 10 10 14 10. 1 2 3 4. Okay, we don't get a shell back. That does not work. So is Netcat installed on the system? It should be because it's a Linux system and it's default. Let's find out which Netcat. It shows it in bin Netcat. Okay, so it does have Netcat as we expected. So we should be able to use a Netcat reverse shell, which is quite nice. There's two here. This one doesn't always work. I find this one's a bit temperamental, but it's always worth trying once. So 10 10 14 10 1 2 3 4. No, that one doesn't work either. I'm getting a bit panicky. Now we're on this one. 10 10. I don't know why I just don't copy the IP address rather than keep doing this. Let's copy the whole command actually. Run that one. We've got a shell. Lovely. Nice. we can use C99 to run the following and gain a reverse shell. Okay, and this is native as well. Now, people say to me, and I've had a couple of people say to me, why don't you ever upgrade this shell? And I do slightly. I do something like, I do this always, or most of the time, Python command import pty, and then we have pty spawn, and then we can do bin bash, right? And this upgrades the shell to a proper bash shell. But here's the problem. If I run a command like that, and then hit the up cursor key, the arrow, the previous command is meant to come like here. Here, hang on. I can just hit up, right? So people say, why don't you bother upgrading your shell? And quite honestly, I just find it a bit of a faff. But I will. I've got my RTFM here, so it's got all about that there. However, it will also have information on how to do this here, full TTY, probably. Except that's not found. So maybe not, but you know, I can just look it up. Full TTY shell. Upgrade simple shells, right? Shell to bash Python. There we go. Here. And then fully interactive, you know. So this actually, to be fair, can go in here. And then this one can now be removed. Where's that delete bookmark? There we go. So I can basically run this. I've done this part. And then background the shell, update the local terminal, and then bring the remote shell back. So I think then you have to do like reset and screen or something like that. Reset. Oh, it doesn't say screen on there, but I think that's what we have to do. Let's do it. It's been a while since I've done this. So we background the shell, run this, and then reset, and then terminal type, you go screen. And now, who am I? LS, and now I can go up, 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 right? Lovely. This works really well. So there we go. That's what I could do instead. And I have at this point. Let's get some limpies going. Blimey. So we're going to temp. Nice. And what we're going to do is the same as we normally do. We are going to go into here, into previous scripts. And then sudo python 3 mhttp server. So we're running HTTP server on port 80. Put in the sudo password here. And then we can literally just grab wget http 10.10.14.10 slash limpies.sh. Now the beauty of this is if I want to now get PSPy, I can just go up to the previous and then, you know, do it this way. I'm not going to yet. I might not need it. Try not to move too much to the system. Chmod ls, yeah, that's there. And then we can just run the P's. Oh, it's got tab completion as well, so I can hit tab and it'll complete the file name for me. I forgot all about this, right? Sorry, my throat's a bit weird today. Broken pipe, lovely stuff. Get Mario, yay. Okay, let's see what we've got here. So far, simple box. So far, very simple. So let's hope it remains so. Okay, we've got a few possible exploits here. In fact, we've got a fair few possible exploits here. Not in a container, that's good. you can see that's our reverse shell command running there. And that's our limpies command, and so on. So that's not too bad. Okay, I was waiting for this on the right to sort of calm down a little bit. There we go. Listeners sockets. Sorry, I got going as well. We have a database, but that makes sense because if there's users and credentials for the website, that'll be what the database is for. Okay, we've got a few config files, or one config file. Oh no, we have got a few. LDAP, no, please, no. Huh, private SSH keys were found. Well, it doesn't, these are Swift mailer keys, they're not actual SSH keys. It would be nice if I did have an SSH key here, so you can just sign in. It is not the case. So we have October CMS password. This is the database config file. So I'm making note of that. That's meant to be gain. Limpies shows. Okay. So we could download this file and then log in with credentials and see what else is in the database. We'll keep that in mind. What else do we have? PGP keys, that's for emails and for signing anyway. Sewage files, normal, not normal. Overflow. Oh, what? Is this a buffer overflow? If it's a Linux buffer overflow, this is a bit trickier than the Windows ones. We last did a buffer overflow in BrainPan. Yeah, BrainPan. And just a reminder of BrainPan. It was the doing all the shellcode and everything. Yeah. Okay. So in Linux, this is going to be a bit trickier because, well, I'm not sure. Let's figure it out. Let's figure it out. We'll come back to that. Let's keep looking and hopefully there's something else. Not looking forward to doing a Linux buffer overflow, especially, I mean, I'm not sure, it might be a basic one. If it's basic, it's fine. Let me explain the different types of buffer overflow. I mean, there are a few, there are format string and things, but I don't mean that. I mean, when you're trying to, hang on, let me look through this first. When you're trying, oh, hang on, I saw something there. October CMS password. Is that the same password we already had logged though? It is, so I'm not too worried about that. Okay. Great. Right. Basic buffer overflows is where you overflow the buffer, and then overwrite the return address so it jumps to the pointer and then it runs the shellcode. It jumps to the shellcode that you, right? That's the basic one. Sometimes that doesn't work, and when a program crashes, it goes to an error handler. For this, you need an SEH overflow. So that's something different altogether, okay? Sometimes there's not space to put your shellcode on, you know, where it would normally go on the stack, and it's somewhere else. And you don't quite know where, but it is somewhere else. You just, every time you run it, it might change location, so it's difficult. There's no way you can jump directly to it. So for this, you need to use an egg hunter. And all this really is as well as the shellcode, you also put a little bit of code known as the egg. And then when you do your overflow, there's a tiny bit of code which might fit, even though a full shellcode wouldn't, on the stack. And what that code does, it runs and it searches for that egg, and once it finds it, it can run your shellcode. So that's the egg hunter. There's also all sorts of protections. There's address space layout randomization. We'll deal with that if we have to. Not fun. There's also things like NX, which stops shellcode from executing on the stack at all. So buffer overflow, you can't get reverse shell. And then there is like 32-bit and 64-bit, which have like multiple more registers, and so it's a nightmare. It really is horrible. So I'm hoping for a basic one, but we'll see. Let's check out Overflow. Let's check out Overflow. Where are you here? Could do with a CD there. Yeah, fine, got you. So this file is SUID, which means if I run it, it runs as root, meaning, as you can see, it's owned by root. It runs as root, and we should be able to run it. Input string. So hello, and that runs okay. Yeah, so that seems to be okay. Overflow file, just give an example, does this. Now I'm going to try and crash it. If we get some sort of core dump or segmentation fault or something, it likely means that it's vulnerable to buffer overflow. So we're going to run this with, like, I don't know, 1,000 characters or so. Maybe that's overkill, but let's do some Python here. So when you're using bash with Python, you've got to put it inside like a variable here. So we're going to run Python, and the command we're going to run is between there, print a, like the letter A, multiplied by 1,000. And we're also going to put 4 B's at the end so that we can try and overwrite the return address as well. Segmentation fault core dumped, right? So that's absolutely, well, that is absolutely buffer overflow. Okay, so let's copy that. We're gonna have to deal with a Linux buffer overflow, guys. Okay, let's check for protections. I can't remember how to do this. Let me just go find my book. Back when I was doing OSCE and the course Cracking the Perimeter, I have a book based on like the debugger GDB and everything. When I was doing Vivek Ramachandran's course, which is free and very good, by the way. So I've got everything in here about egg hunters and ASLR and everything like this. So let's take a look. We're first going to, what we're going to do, check for ASLR, right? So according to this, it's in proc sys kernel. Hang on, get rid of that. So cat proc sys kernel, and then randomize VA space. If this is 0, it means that ASLR is disabled and we're going to have a really good time. If it's anything other than 0, it's not going to be nice. Okay. Right, ASLR is enabled. What this means is that it's difficult to explain in layman's terms, but I'm going to give it my best shot, right? Let's say that if you run a program which uses many modules, a module is fixed here. And so when you're at this address, whatever that address may be, which means that when you are trying to jump to it to use one of its functions, you know exactly what address to go to every time. Address space layout randomization, ASLR, means that every time it's in a random place, so you can't jump straight to it. It's impossible to do that because you never know where it's going to be. And there's a way to actually prove that this is the case as well, according to this, and that's LDD. If we run LDD with the overflow, you'll see that the C library, which is what we like to use here, is 759E00, or B759E000. And if we run it again, you'll see that now it's at B7561000. And if we run it again, it's now at B75E200. So it always ends in 000, and it always starts with B75 by the looks of it. Oh no, B76. So it starts with B7. Okay. So the first question is how to bypass ASLR. There are ways you can do it where you overwrite just a couple of characters, a couple of bytes in the address, but I'm not thinking that way because everything is between B7 and the 000. It's only really these three values that are changing each time, right? Which means if you run it for long enough, as many times as you want, you'll eventually hit upon the same one more than once, right? You must do. If you run it infinite number of times and there's only a finite number of values, you're going to run the same one twice, at least once, right? The difference between this and what we did in BrainPan is that in BrainPan, we tested it on our own system, and then we ran it on the target. And if it didn't work on the target, then that crashed. The similar to this. Look, if I just do this now, one sec. If I do that and run it, it crashes and shuts down. That's what happens on Windows. But there, we didn't have access to get it running again, at least not as root. Here we do, because of the suet. So we can run this as many times as we like. Okay, so I'm going to write a little bit of code just to show that it's going to hit the same value more than once. Okay, so I'm just going to put here proof this is this. However, we can restart the app each time, and eventually it should hit the same address more than once, right? So if let's do it manually first, and then I'll write some code if that doesn't make much sense. We're going to do this, and we're going to look for, let's just say this one. Doesn't matter which one, any of them, because they'll all be hit more than once. We're going to grep for that value. If it comes up with that value, it doesn't exist this time. But we go and we run it again, and we run it again, and we run it again, and eventually it will come back to that value. So I could do it like that, and it might take a while. I could also write a loop. Yeah, it might take a while. So what I'm going to do is write a loop. Just to put whilst true, so while, forever, we're just going to keep running this code, and then we're done. That's what this code does, so off we go. It's going to keep running it. There we go, it's hit it again, and again, and again, and again, and again. No, there's not been any for a while. Is it going to hit it again? It is. Right, do you see what I mean? So we can basically prove, put it this way, if we use this value as the base for our the modules to jump to, right, and our code doesn't work, we just keep running it in a loop until it does, until that's aligned. Hopefully that makes sense. It's a bit of a tricky concept, bit of a tricky concept. So how do I get back to, there we go. I hate the fact that this is cut off. Okay, so while true over, that's all I need to do anyway, so there we go. So if I run that code on the target system, it will hit it a few times. So now ASLR is not a problem, because it doesn't matter that we don't know where it's going to jump to. As long as we have an address that it's hit before, it will eventually hit it again. So we can use that as our fixed address. Hopefully this makes sense. Okay, ASLR bypass. The next thing we need to look for is see if NX is enabled. How do we do this? Look through the book. Check sec. Not sure if I can do that on here or if I need to do it on my machine. Right, okay, I need a copy of it on my machine then, in that case. How do I get this to my system? I can put it in the web root. Let's try that. Let's just put it in the web root. Let's hang on. Where is the web root? Where's the web root that we can write files to? Here. Here, okay. So we're going to copy Overflow to there. Okay. Which means technically now I can go here. Hang on a minute. Download it. Yeah, brilliant. Okay, so that works. There are other ways I can do it via Netcat or so on, but if you've got something which works, let's not complain too much about it. Nice, nice, nice. I'm just going to put we copy Overflow to the web root and download. Easy enough. Easy enough. And in fact, I'll do that because it's not even the web root. It's just somewhere in, you know, I'm just going to put to the CMS directories. Okay. And download. There we go. Okay, check sec. Let's take a look. There we go. Nice. Hang on, let's make Overflow. Make sure it still works on this system, to be fair. Overflow input string. It works fine. It works fine. Okay, so we're going to run checksec on Overflow. Not found. Yay. Sudo apt install. Okay, installing software as we go. That's fine. This is a relatively new laptop, and most of my no, I've got this wrong. This is an old laptop, and most of my stuff is now done on a new one, so I don't have all the tools on this yet. But that's okay. So I'm rather hoping that NX is disabled, because if NX is enabled, it means that we can't put shellcode on the stack because it won't run, it won't execute. I think NX must stand for non-execute, I'm not sure. No execution or whatever. No option selected. I'm not sure what that means. Let's use help. Oh my god. Checksec formats file. Do we just need file? NX is enabled. Oh no. And there's no pi. Uh-oh, there's no pies. That's not good, friends. We love pi. Right, don't worry about pi. We're not worried about that too much. NX is enabled. Okay. That's meant to be copy. NX enabled. So we cannot use shellcode because it'll never run, even if we're able to reach it. There are a couple of ways. I think maybe the most logical will be a return to libc. I think so. Okay, I've got details of this in my book, but I want to try and find it somewhere else. Ret to libc just to show you kind of how it works roughly. Wikipedia is never a good one because it's just way too complicated. Let's try this one. Am I still in frame? I am still in frame. I'm getting small. Okay, it's only concerned with... Okay, that's fine. We're not worried about that. So... Good sentence, that one. Enables some attackers to bypass the NX bit protection and subvert the vulnerable program's execution flow by reusing existing executable code from... It does make sense. So it's going to use code from this C library. Now, we've already found this C library, haven't we? We did... Yeah, lib, so C, that's the one. So it's here, this library, libc so 6, that's what I meant to say, libc, okay, fine. Right, this is going to be complicated. Let's use the diagram, see if it helps us. I'm not sure how well you can see this. So before the overflow, the stack, it has variables on there, and it has EBP, and then a return address and arguments, right? But what we want to do after the overflow is system. So it's calling the system function of libc, and then it's going to exit. And what exit does, it pops this off the stack, and then it appends bin sh, and so it's going to run as a system. It's going to run as a system command, a new shell. If that's complicated, don't worry about it. You don't need to know how it works. You just need to know what to do to make it work. But if you can understand it, then this site, definitely take a look. I mean, if not this site, then any other. Just search for ret to libc and learn something. Seriously, it's going to really help you, I promise. So I'm not going to go any further into how it works. I'm just going to go into the fact that we need to find the system function, the exit function of that library, and then we also need a bin sh or bin bash or something going on. So EIP is overwritten with the address of system in libc. So these are the things we need: address of the system function, address of the exit function, and address of the bin sh string. So we need the following. Now, there's a problem. There's a problem in that as much as I can just look for the addresses of those functions, I'll give an example, actually. Let's have a look at my book, see what I can find. According to this, read elf is going to be quite useful. So we need to do this on the system. So we're going to read the executable Linux file. And we're going to use S to get the S gets the address. Well, symbolic as well. I know what I mean. Not symbolic. Relative address. So maybe we shouldn't put S because I'm trying to prove a point here. Let's do this. I'll explain it all in a second. Right. So do that. And then what? So yeah. If I do that, here's S. Yeah, symbols. That's the one, symbols. Okay, so let's do that. We do need all the symbols. There we go. So this is all the modules and all the different chunks of this app, right? We're looking for, we're going to grep for, well, what do we need? We need exit and system, right? So system first, because it goes in reverse. The stack's always back to front. So we're going to do system, and then exit, and then, you know, bin sh. That's the way it's going to work. So we're going to look for system first, and you'll see a problem if I do this straight off. We're going to grep for system. And if we do that, Do you see how there's 3? Now I know the one we need is that because it ends in at, but just to round it down, what we can do is, well, we can do system at, but you'll see that there's one there and there's one there. So we need to make sure that there's nothing before system. It needs to be absolutely at the start. So we're going to do space system at. So that is the one we want. We're going to do the same with, hang on, let's do the E flag so I can do multiple. We're going to do the same with exit. So now you can see exit is here, system is here, and now these addresses, you'll see that they start with 003326, start with 3 zeros, and then you've got that. Every time I run this, these are the same. These ones don't change, despite the fact that I am, there is ASLR, these don't change. The question is why? The answer is that these are relative. These are relative to, I'll show you what I mean. The base of this file is here, and it changes often, right? It changes often. Whoops. No. What? Go away. Right. The base that we're using is this, but it can be any of the other ones, right? That is the base. And then we say, relative to the base, we have this. Okay. Hate this truncated crap. It's so annoying. This is sometimes why I don't upgrade my shell. And yes, I know that I can change my column width or whatever, I just can't be bothered. Right. So the base is this, and if we add to it this, then we get this. And the base is this, and if we add to it this, we get this. Now you see the problem, because this is the same each time relative to this, but because the base changes every time, we can't just jump straight to there. Yeah. So nightmare, right? So we'll deal with it. That's what we're using as a base. It does change, but as we know, it eventually comes back around. So what we're going to do at this point, we need to find, I'm not got any notes on this now. So let's take a look here and see if we can figure out how, oh, don't freeze. There we go. So that's got ASLR off. So it's finding system by doing this in GDB, but I don't want to do that. It's got to be another, well, we've already done that. We found system in a different way, and we found exit in a different way as well. Now this one, finding bin sh, this is what we need to do, because we need to call system bin sh, you know. So how do we do it here? Oh, it does it using GDP. I don't really like that idea, because it means installing a debugger on the target, and I really don't want to do that. I can't do it on my own system, because my own system, I might be able to. I don't think so. If I do it on my own system, then it might be totally different architecture or totally different something. But you can see that it has the strings utility here. So I could copy this and use this to find bin sh. I just need to make sure the file is right. Oh, what's happened here? What a mess. I really hate this truncated, awful. Right, that's better. So this is the file we need, rather than the one that the example uses. And it's just looking for bin sh, that's what we're doing. The T here with the X after it means that it's going to be output in hexadecimal, which is what we need. So, can we clear? Does that work? It doesn't work. Okay, let's try that. What has just happened? Useless. Right, strings AT, blah, blah, blah. So it finds it at 162 BAC. Okay, I'm just getting even more complicated now. We can see this as 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. We can see this as 0, 0, 0, 162 BAC. Similar to that being 0, 0, 0, blah, 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 0, 0, 0, blah, 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 I think. Or 0, 0, whatever it is. Okay. So now we need to do the math, which I think is going to get us doing here. It means in our vulnerable program address this, you can see the string here. Okay. Okay. Right, I'm not going to use this site anymore. From this point, we have to do some math. So, therefore, we add the relative addresses to the base to get the final locations. But of course, the base changes, so it's going to change. That's okay. So let's start with what have I put in my notes here? Okay, system plus exit plus bin sh. So we're going to start with system, and then exit, and then bin sh. So let's do system first. System is here. And the base, actually, let's copy the base first. Let's get a calculator out. Let's do some hex math, hexadecimal. Hexadecimal, there we go. So we have this added, we add system to this. There we go. That is the location of system when base is this. When base changes, that's going to change as well. By the same offset, but regardless. So now we do the same. We take exit, which is this one, and we add it to the base. It's all about the base, buttery biscuit base. So we'll go back to that. And put that in. That is the location of exit. And then bin sh is here. We do the same again. We take the base. It's all about that base. And this is the location of bin sh. So when base is this, those are the locations of what we need. Now, what our code needs to do is, this is how the code will work. We need to overflow with junk until we find the place to put the return address, and then we're going to put the return address, which is going to be system. Is that right? Yeah, I think that's right. So system, which is going to be this in little endian, so backwards, 10, 33, 60, B7. That's system 10 33 60 B7, and then we're going to add exit. No, am I getting this the wrong way around? Am I getting this the right way around? Let's take a look. Let's just take a look here, just to make sure that what I'm saying is right, because I don't want to get these mixed up, right? It shows that we need in this order, system, because everything goes backwards, system, exit, bin sh. Okay, so that's right, that's system. Exit is 60, 62, 5F, B7. 60, 62, 5F, B7. And then we need the bin sh finally. And this one is AC, 5B, 72. So I'm just being very careful, making sure, because if something goes wrong here, it's going to mess me up. And B7. So we're going to overflow with junk. And I think that's it. I mean, we need to know whereabouts to put this. Now, do you remember when we ran this and we had and we had those okay, right. Okay, what we did before is we ran Python, but we need to use Python 3 this time because I'm on my system now. Oy vey. Right. Okay, we're running Overflow, and then we're doing a Python module, not module, code, Python 3. And in here we need to do print, and because it's Python 3 we need those. And what we're going to print is A multiplied by 1000 plus 4B's, right? That's what we did. Okay, let's try that again. With that. No, without the 7. Right, good. So that works. 1000 A's is too many. It's causing an issue. The question is, how many do we need to do so that these 4B's are overwritten by this? If we can manage that, we've got the whole thing. Right, so that's the question. That's the question. So what we're going to do is we're going to run GDB, which is the GNU debugger. My sore throat's getting worse. And we're going to run it with Overflow. There we go. So we're running GDB Overflow. So let me just put that in there. We need to find the offset to overwrite. So we're going to do this, and now we're in the debugger. We're going to run the program with this. And you'll see that 41, 41, 41, 41 in hex are A's. That's not the right place to look for that. ASCII table. .com, .net, .whatever. We need an ASCII table of some kind. 41 in hex. 41 in hex is capital A, and 42 in hex is capital B, right? So that means that 1000 A's is too much because it's overwritten where the B should be. that should show 42, 42, 42, 42. Does that make sense? Which means now we can either do a pattern, create a pattern and then find the offset using this, or I quite like doing the trial and error method. I really love the trial and error method, and I really, it's quite fun to do. So we're going to halve it. We're going to try 500, not 5,000, 500, starting from the beginning. And you'll see A's still overwriting. So let's halve it again. Let's do 250. And it's still A's. So let's halve it again and do 175. And these are still A's. So let's get it down to 150. Okay, let's drop 50, get it to 100. Okay, so it exited normally this time. So 100 A's wasn't enough to crash the program. 150 was too many. So now we've rounded it down. We are between 100 and 150. So the logical thing to do will be 125. Too many. I'm just going to drop 5 at a time now. 120. So now it's between 100 and 120. Let's try 110. Oh, we're starting to get our B's. So 111 is 3 B's, and 112. Okay, we need 112 bytes of junk before whatever we put here overwrites what we need it to overwrite. Okay, trial and error method. It doesn't take long. It's quite logical as well. So we need 112 bytes of junk. Okay, so our final code should hopefully be let's take a look. Just have a look, see what we've already done. Don't mind me. Okay, so our final code should hopefully be, but I need to do it for Python 2 this time. So we're going to do Python, and we're going to get rid of these brackets because Python 2 doesn't use them. Let me just check that this actually runs okay on the system. Yep, okay, that's fine. So now all we need to do is swap that out with, oh, watch out for these quotes. Watch out for these quotes. This really messes me up quite a lot of the time. Oh, come on, get with it. This is the only thing I don't like about Cherry Tree. Messes with your quotes. Everything else is fine. Okay, let's grab that and put it in where these B's are. So we've got running overflow with 112 A's, then we're overwriting that return address with system, and then exit, and then bin sh, and that's the way it should work. This should work. However, as we know, the base address is different. And we can keep running it like this until we get root if we want, assuming this even works. Segmentation fault is quite an interesting one. But we could also run it in a loop as we did before. So while true, do this. and then we're done. Legal instruction. There's all sorts of weird things happening here. I'm kind of hoping I've done everything right. It shouldn't really be taking this long, I'm fairly sure. Oh! Who am I? Wow! And there we have it. Eventually it aligned, and the base address was this one time, the one that we chose. Everything else, you know, every other time it was different. We put this in a loop. So let's grab this again and show our loop. While true, do that. Done. That's our code, and we was able to return to libc, and it was running system bin sh, and we got it all there. Lightning struck. Let's grab what we need to grab. We're going to go cd home, cd, well, just cats, Harry desktop. Really? Okay, I'm gonna cat Harry. Oh my god. Do you not need to do that? Right, let's stop being stupid. Let's cd into Harry as well. Aha. So cat, well, print working directory, and then cat user dot text, and then cat root. What am I doing? Cat root. There we go. Oy vey. That was interesting. It was difficult in its own way, but thankfully, due to my notes, manageable. Let's get this finished. I'd love to see what I'm not bothered about actually completing the guided mode this time, but I'd absolutely love to see what they at least ask. How many ports are listening? I can't remember. 2. What is the name of the content? Okay, October CMS. What is the default password? Admin. PHP 5. www data, right? What user is the website running as? Huh? Is that the same? That's a stupid question. User flag. I assume is that one. What is the full path to the file owned by root that has set UID permission? Yeah, user bin October or something weird like that, isn't it? I can't remember. I think it's something like that. That was very easy to get into. I think it was user bin October, overflow. It wasn't user bin overflow. What was it? Okay. I guess let's go back through my notes and just look for the Limpy's output. Use a local bin overflow. Okay, that's fine. Okay. How many bytes into the user provided data will overwrite? 112 it was. Oh, that's all it asks. Use a tool like pattern create to make a long pattern and pass it into Overflow while running in GDB. Look at the data in EIP and use pattern offset. Or you can just use trial and error and try 1,000, then 500 and 250, whatever. If it works, it works. I quite like doing the trial and error, but it's easy enough doing it otherwise. It doesn't ask much else. I thought it might about ASLR and stuff like that. And reptilipsy, you know. What a very interesting system. This very loud. That was really good. That was really good. I enjoyed that one a lot. Good. If you were confused about some of the concepts there about buffer overflow, I wouldn't worry too much about it. Buffer overflow is relatively rare these days in the wild. It does still happen, but not as often. And you know, buffer overflow is basically a field unto itself, going into assembly and things like that. So don't worry if you're early on in your pen testing journey and panicking about this. You will very rarely have to use it, but it's good to know. So put it on your to learn list, but don't put it high on the priority list. Okay, it's just something when you've got time. They are great fun. They are really good fun. They're like logic puzzles. They're basically like puzzle boxes. So you move something and then something else moves and then you're able to get into something, but there's something else is blocking you and so on with all these protections. So definitely learn it, but don't worry about it. That's my advice. Thank you for joining. If you enjoyed this and you've still got most of your brain cells intact, please leave a like, please subscribe, share the video, share the playlist if you can, and please visit nethemba.com for all your pen testing needs. Thank you so much. Goodbye.